In this video, we're going to integrate products of tan x and secant x. So here we have tan x to the power of m, secant x to the power of n, integrated with respect to x, where m and n are positive integers. So our strategy will be, if the power of secant is even, factor out secant squared x, and replace remaining factors of secant squared x in terms of tangent x, using a trig identity 1 plus tan squared x is equal to secant squared x, then apply U substitution, let U be equal to tan x, and its derivative du is equal to secant squared x dx. So basically all we're doing is using a trig identity and U substitution. Now we have another case. If the power of tan x is odd, factor out sec x tan x, and apply trig identity tan squared x is equal to secant squared x minus 1, which is the same identity we looked at before, just rearranged, and we'll replace the remaining factors of tan squared x in terms of secant x, then substitute u is equal to secant x, and its derivative du will be secant x tan x dx. So essentially, again, it's just using a trig identity and u substitution. All right, let's look at some examples. Here we have integral tan to the fourth x times secant to the sixth x dx. So let's write that down. Integral tan to the fourth x, secant to the fourth x times secant squared x dx. So notice we factored out secant squared x. We rewrote this part secant to the 6x as secant to the fourth x times secant squared x. All right, so now let's rewrite this as tan to the fourth x times secant squared x all squared times secant squared x dx. Now we're going to apply a trig identity and change this part in terms of tangent x. So we have integral tan to the fourth x times secant squared x is just going to be 1 plus tan squared x all squared times secant squared x dx. Now you can see the motivation behind these steps. We like everything to be in terms of tangent x so that we can use U substitution, then its derivative will be sec squared x dx, and it will cancel out this part here. So let's apply U substitution. We'll let U be equal to tangent x, and its derivative du will be secant squared x dx. So this part, tan to the fourth x, is u to the 4. This part will be 1 plus u squared all squared, and this part, sec squared x dx, will be du. All right, so we have integral u to the 4 times 1 plus u squared all squared times du. Let's FOIL out 1 plus u squared squared, so we have u to the 4 times 1 plus 2u squared plus u to the 4th, integrated with respect to u. So I'm just applying some basic algebra. If you have a plus b all squared, that's going to be a squared plus 2ab plus b squared. All right, so now we're going to multiply out u to the 4. Let's distribute it and simplify this integrand. So we have integral u to the 4 plus 2u to the 6, because u to the 4 times 2u squared, the bases are the same, we add up the exponents, plus, and u to the 4 times u to the 4, add up the exponents, and we get u to the 8 du. So now we're going to integrate term by term, reverse the power rule. So what we're going to get is u to the 5 divided by 5. Applying the reverse of the power rule to u to the 4, add 1 to the exponent, divide by the same number, plus, and integrate 2u to the 6, reversing the power rule, we get 2u to the 7, divide by 7, and integrate u to the 8, we get u to the 9, add 1 to the exponent, and divide by the same number, plus c. Now we need to get everything in terms of x. We need to get it back to x. So that's going to be 1 over 5 tan x to the power of 5 plus 2 over 7 tan x to the power of 7 plus 1 over 9 tan x to the power of 9 let me erase this part here so I can add a c plus c, and I'll put this back in. Our substitution is u is equal to tan x. All right, so what we have shown is that the integral of tan to the fourth x secant to the power of 6x dx is what we have above. Not too hard. All right, let's look at another example. In this case, the power of tan x is odd, so we're going to apply a different strategy. So let's rewrite this integrand, and we're going to factor out tan x sec x from the integrand. So we have integral tan squared x secant to the fourth x times tan x sec x dx. All right, so now let's apply a trig identity, and let's rewrite tan squared x, this part, in terms of sec squared x minus 1. That way we have everything in terms of secant x, and we can apply U substitution. So we have secant squared x minus 1 and times secant to the fourth x times tan x sec x dx. Now we're going to apply U substitution, so we let U be equal to secant x, and its derivative, du, will be sec x tan x dx. So you can see the motivation behind our steps, because this part here is going to be u squared minus 1. This part, secant x to the power of 4, will be u to the 4. And now all of this, tan x sec x dx, is du. So you can see we now have an integral, a simple integral in terms of u that we can solve. So what we have is integral u squared minus 1 times u to the 4 du. Let's distribute the u to the 4, and we're going to get u to the 6, because u squared times u to the 4, same base, add the exponents, minus integral, that's u to the 4 du. And now let's integrate that. So we get u to the 7, reversing the power rule, divide by 7, minus u to the 5, divide by 5, plus c. Now we have to get everything back in terms of x, so let's substitute u is equal to secant x, and what we get is secant to the 7x, divide by 7, minus secant to the 5x, divide by 5, plus c. So what we have shown is that the integral of tan cubed x times secant to the 5x dx is equal to what we have above. Let's rewrite that as secant to the 7x, divide by 7, minus secant to the 5x, divide by 5, plus c. All right, thanks.